high-purity alumina ceramic locating pin, a precision-machined positioning element with a conical aluminum oxide tip, a cylindrical shank, and a flanged mounting base. ADCERAX manufactures these pins as wear-resistant, electrically insulating locators for welding fixtures, sheet metal stamping jigs, and precision assembly tools where metal pins fail under repeated contact, weld spatter, or stray current. 5 material properties make high-purity alumina the optimal choice for welding and precision locating applications. First, Mohs hardness of 9 or above, second only to diamond, allowing the pin tip to withstand hundreds of thousands of sheet metal loading cycles without wear or deformation. Second, dielectric strength exceeding 15 kilovolts per millimeter, providing complete electrical insulation between the workpiece and the fixture, eliminating the parasitic current paths that plague metal locating pins in resistance welding. Third, a dense, non-porous surface that weld spatter and molten metal cannot adhere to, so the pins stay clean and dimensionally stable across production runs. Fourth, thermal stability, up to 1600 degrees Celsius, well beyond the transient arc and spatter temperatures encountered during spot welding. And fifth, precision machining tolerances held to plus or minus 0.01 millimeters, delivering the sheet positioning accuracy required for modern body-in-white assembly. The 3-part geometry of the alumina locating pin corresponds to 3 distinct functions. The conical tip guides the sheet metal hull smoothly onto the pin as the operator or robot drops the workpiece into the fixture. The cylindrical shank, precision ground to the whole diameter, holds the sheet in its correct position with 0 lateral play, and the flanged base seats securely into the fixture plate, with a shoulder that sets pin height exactly. At ADCERAX machines, all 3 sections from high-purity alumina 95 to 99.7%, with tip angle, shank diameter, shank length, and flange dimensions, fully customized to your fixture drawing. The most typical application for alumina ceramic locating pins is the resistance spot welding fixture in automotive body-in-white assembly, and this single application maximally exploits every property we just reviewed. On a modern car body line, sheet metal panels are loaded onto welding fixtures at a rate of hundreds of parts per hour, and robotic weld guns fire tens of thousands of amperes through each joint. A metal locating pin in this environment faces 4 simultaneous attacks. First, the sheet hole repeatedly drops onto the pin, grinding the tip and shank. A steel pin wears out and loses positioning accuracy within weeks. Alumina's Mohs 9 hardness eliminates this wear. Second, weld spatter sprays across the fixture every cycle. Molten steel droplets fuse onto metal pins and eventually build up into a crust that prevents the sheet from seating. The dense, non-porous alumina surface rejects spatter, so pins stay clean across entire production shifts. Third, and most critically, a conductive metal pin creates a parasitic electrical path from the workpiece to the fixture body, diverting weld current away from the nugget and causing cold welds or inconsistent strength. Alumina, with dielectric strength above 15 kilovolts per millimeter, completely isolates the sheet from the fixture, forcing every ampere through the intended weld joint. And fourth, arc heat and spatter would expand or soften a metal pin over time, but alumina maintains dimensional stability up to 1600 degrees Celsius, holding fixture accuracy across hundreds of thousands of cycles. From door frames to B-pillars, from robotic MAG stations to servo-actuated spot weld cells, alumina locating pins are the standard positioning element that keeps body-in-white tolerances tight and weld quality repeatable